Hello everyone, this is JT Peterson, Director of Software Sales North America and Head of Global Marketing for ETA. Thank you for joining us. Today, Jenson Chen, our Vice President of International Sales and Dynaform Product Manager, is about to walk us through the technical presentation of key features in Dynaform 6.2. Jenson's just gotten started, so let's go ahead and join in.
Center line of the tube, and then setting up the bend dies and conduct the simulations, okay, for this tube bending example. And then the next example will be on tubular hydroforming design and simulations. In this case, we will also design the hydroforming die based on the shape of the products. Let me fire up my Dynaform here. I'm gonna start a new project. Okay, so in this case, let me name it tube bending. Okay, and pick tube forming option here at the startup. You will see the tube forming dialogues being displayed. The fonts here, or the items listed in red, means that we have to define them, and then the blue one is optional, right? To start with this, I have to click Define Tube, bring in my tube product. We don't have it from our Geometry Manager, so I will go ahead to click Import and select Tube Bending Model. I'll pick this one. Okay, this is a tube here. We have this geometry here. Now we will select this geometry, all right, and click Include button, and exit. Okay, right here, Dynaform already mesh the geometry. You can view the mesh later on if you can use this display options, display the element edge. You also notice there is, all right, we have the start of the tube and then also the end of the tube. All right, you can define the start of your tube, all right, and then you can also define the end of the tube if the one that's defined here is incorrect. Next, we will go to click the material button here. Okay, let's say we are going to pick BP780. If you have other materials, you can also click Import. All right, we do support a different material formats. All right, you can click Import to rig in your material definitions. I'm going to click OK here and key in the thickness of the tube, which is 1.2. Next, I will go to the tipping function here. You say my tube is not properly tipped, so I'm going to choose the automatic options and click the minimum draw depth so that I can tip my tube in Z directions. We can move on to morphing. Again, this is optional because it's listed in blue. If we don't have any holes in the tube, then we can skip this step. But in this case, we have 4 holes. So I'm going to go and pick one of the options here. There are 3 options. One is end fill. So you have some protrusions. You can use this end fill to fill that protrusions. Now, in this case, we have the hole. So I'm going to pick the fill hole options and click Apply. In some tubular hydroforming products, you may have a notch. Okay, then you can use this boundary fill to fill the notch of the tube in. You can use find holes or remove buttons here to add or remove the hole fills here. Next item I want to do here is to calculate the center lines. All right, there are 2 options in the center line calculations. You can use either geometry, which Dynaform will automatically calculate the center line based on this tube geometry, or there is a manual options where you can manually create the center line. Okay, so in this case, we will use the simplify options here by clicking calculate, and you can see the status bar here. Dynaform is calculating the center line of this tube. Once it's done, you can see that the center line is being highlighted in white. And then we have a sections which is normal to the center lines. You can click your left mouse buttons and drag this center lines. I mean the section along the center lines. All right. As you drag along the center lines, you will see this change of circumference, all right, of the sections on this graph here. You can also look at the circumference, okay, and the strain, okay, the strain. You can look at the strain. Okay. At the same time, at the end of the calculation, you also know that what is the diameter of your tube and the length, okay, of this tube. Okay, in this case, it's 1,483 millimeter. Okay, so once this is created, then we can move to the next steps, which is creating the tube forming process. Okay, there are tube forming process, preform, hydroforming, and trim operations, and there's annealing. Okay, in this example, we will just click left mouse button and drag this icon down, okay, and click OK to generate the bending steps. Okay, so we will go to bending data here. As you can see, there's nothing here in this list. So what we want to do is to use the automatic functions to create the bending steps. For some user, if you already have that, drawings, you can use add or insert function here to add your bending steps. Okay, but in this example, we are going to use the automatic features. You can see how fast it is for Dynaform to automatically calculate the number of steps required to bend this tube. And then there will be a feed, okay, which is S for each step. And then there is rotation of the tube. So we call that A, right? And these are the angle of rotations. And then they have the bending radius, which is R, right? We have this bending radius. And then we have the bending angle, which is B, okay? In this case, right? If you're okay with all these default parameters calculated by Dynaform, you can click create bending steps. Right? If not, you can also use a specified radius. Sometimes you want to have some special radius. Okay, user-defined radius. You can list here, and then the number listed here will overwrite the one calculated by Dynaform. Okay, in this case, we will click bending steps. So as soon as you click bending steps, this forming simulations tab is activated. Okay. Then you can go to this window, all right, and move on to tube, okay, and here you can click apply. Okay. Once you click apply, you will see that the tube is being created, all right, and using the mesh size of 6 in the axial directions and 6 mm in the radial directions. You can modify this, right? If you want to further refine this, and in this case, I'm gonna click show for you to look at the elements, right? If you think this is too coarse, you can modify this numbers. You can delete it. Okay. Let's say we are going to delete this and then use, let's say, 2 and 2. Okay, then click apply. Okay, you will see that now we have a refined elements on this tube. Okay. Next, we're going to define the operations. Okay, the tube bending operation, that is. In Dynaform 6.2, we offer 2 methods for the user to calculate the deformation of the tube. Okay, one of them is using the one-step approach, or we are using our M-step to calculate the deformation of the tube. We have the stress strain and the thickness calculations based on one-step approach, or use the incremental approach. All right. In this case, we are using LS Dyna, okay, to run the tube bending simulations. Now, as of tools generations, you have wiper die, die insert, and mandrel. Mandrel is optional, but in many cases, the user will add the mandrel just to ensure that tube is being bent properly. We will use the default setting and then click create, generate the bend dies and the accessories, okay, on the wiper die. Now, if you want to modify, these bending parameters, you can go in to individual steps to modify it. You can change the mandrel. Okay, I'm gonna display just the mandrel. Okay, in this case, we have, let's say we want to modify the shaft length, from 210 to, let's say, 500. All right, then we can click apply. So you will have the new length. Now, if we want to add the number of mandrel balls, then we can change the number here from 3 to 5. And interval seems to be a bit big, so I'm going to reduce that to, let's say, 5. Okay, and can click apply. So here you can modify the balls in your mandrel assembly. There are also other options available, such as feeding. You can add feeding of the mandrel, so this is additional options. I'm not going to demonstrate these features. Now, if this is okay, you look at this mandrels and assembly, everything. Once it's done, then you can click on animations, okay, to kind of preview, how this tube will be bent. So there will be different steps that's being shown here, either with the feeding or no feedings. We can check that. All right. So once this is done, we can go ahead to check the control parameters. There are different control parameters available. These are usually for advanced user, where they want to have a specific user-defined parameters, such as self-contacts or integration points or element formulations. Depends on who is using it. If you want to include spring back, then you might want to change formulations and the integration points. So I will leave this as it is and then move on to job submissions. In this case, we can submit the job using either the SMP versions or the MPP versions. Once you pick that, you can click submit jobs to run the simulations. I'm not going to run this simulations because I already have the result of this. Okay, so I'm going to show this. In this case, I already hide the tools and I just show this. Conduct the tube bending simulations. Okay. Right. If you don't use this play button here, you can click your left mouse button and then drag the dot here to kind of speed up, okay, the tube bending process. Of course, you can display, for example, the thickness, okay, or the thinning. Show the thinning of this, okay. So in this case, we probably might have some failure on the extrado of this bend tube. And then as you can see that there are also significant wrinkles, okay, probably due to a tight bending radius, large bend angle, okay. So I think that's about it for this example. Next example, okay, which is a bit more complicated because we have to do many different steps for this tubular hydroforming example. Okay, so again, I will create a new project. Okay, in this case, let's call it tubular hydroforming. Okay, click OK. Okay, we have a project here. Now I'm same thing, gonna click define tube to import tubular example. In this case, have this much more complicated examples. Okay, so I'm gonna click exit and then select this hydroform tube, click include button and exit. I'm gonna define the material In this case, let's pick DP600 and click OK. And the thickness is 5 millimeter for this example. I think the part is already properly tipped, so we don't have to. We can skip the tipping operations. As for morphing, you can see that there's quite a number of holes available here on this tubular product. So again, we will pick fill holes and click apply. All the holes will be filled. Next, we are going to calculate the center line of this tubular product by clicking calculate. Okay, as you can see, the diameter of this tubular product being automatically calculated. Okay, and along with the length of the tube. Since this is a tubular hydroforming product, we usually want to start with smaller diameter. In this case, I'm gonna go with 60. All right. Now, once we do that, I'm gonna go to the strain tab here, so we can kind of drag the sections and check the maximum strain value. So if you want to start with much smaller tube, let's say we go with 55, you can see that the strain value will be higher. Okay. All right. In this case, you will see a crack for sure. So I'm gonna go with 60 just to reduce the amount of strain. And then I'm gonna go to click die face. So here we are going to create the bending process, and then the preform and hydroforming. So there will be 3 steps in here. Once we click on that, we are now at hydroforming process. So in here, we don't need to tip the parts, but we can add extensions on both ends of this tube. Define the connections. Okay, the connection is the round right here. That is the connections. And transitions, okay, which is the transition between the connection and initial tube diameter. Then you can also add extensions. So initial tube diameters extension, either you have 20 millimeter or 50, 100, it's up to the user. Okay, in this case, we are going to stick with the default values and click apply. So you can see that it's created automatically by Dynaform. That's from the start, and now we can click on end. Okay, again, click apply. Okay, so we have this extension being created. So next, we're going to move to center line. Again, we are using the automatically options to calculate the center line of this tubular product. Just a few seconds, then we have it. Okay, so again, you can drag the sections to check the initial tube sections and the hydroform tube. Of course, you will have the strain values display. Okay, so you can check that. Okay, all right. Next, we are going to generate the hydroforming dies based on this geometry. Okay, so first things first, we have to generate this, a split lines or separating lines. User can also use the manual options where you can define the location of the split. We are going to use the automatic approach to let Dynaform create a symmetry split line, left and right. Okay, there will be a 2 split line being created here. You can edit the split lines. If it's all good, then you can go ahead to create the 2 flange using the default parameter, the width of 60 millimeter. You can also have the flange angle. Okay, you can set up the flange angle. Now, if this is okay, then we will click separate tools. Okay, as soon as we click that, Dynaform will generate hydroforming dies. Okay, there will be upper and lower die. Next, we are going to define the bending steps. We're going to define the bending steps. In this case, we will use the simplify options. Okay, and then click create bending step. hold on, I'm going to add specific radius. Okay, I'm going to use 125 and 150. So if I click on that again, because I will have preform operation just to bend, or form the tube, so in this case, I can start with a uniform radius. All right, and click again. You can see that Dynaform will just automatically replace the original radius to the one we specify here, okay, which is 125 and 150. Next, we can click create bending steps. As soon as we click that, the forming simulation option is activated. What we have here is the hydroform die, okay, but we will just ignore this because I'm going to define the tube first. Okay, click apply, get the tube. Okay, as soon as we click apply, Dynaform will display, this is like a shape of the band tube, uniform band tube, okay, just for visualization purpose into the hydroform cavity here. Next, we will create the bending. Okay, click create. So this tool will be used to bend the tube, the initial straight tube. Now, as for preform, we will import a geometry. We'll go to click geometry and then import. I have the preform geometry here. This is the one that pre-generated. Okay. Now we're gonna define the upper die for the preform. I'm gonna click on define and pick upper die, select include, and then click exit. Okay. Next, I will define the lower die. Okay. Click here, include, and click exit. All right. You notice that the stroke is a bit further up. We can always go back to change the stroke. Let's say to 20. So to move the upper die down so that we can run the simulation much quicker. Now you also notice there are a couple of places here where we need to have some cam preform. I'm gonna click right mouse button here at OP20 to add cam. Okay, add cam. All right. And here we will click define. All right. In this case, we cannot use the layer options because these are the surfaces. So I'm gonna go to pick select by surface and then pick one of the surface here and click include, click exit. All right. So you notice that the direction of the cam form is not correct because it's listed as -W, which is -Z directions. I'm going to change it to +Y. Now it's being automatically positioned, and the stroke is only 8, but I'm going to use, let's say, 20. Use a stroke as 20, and then pick the cam process. Okay, this is after the main operations. The main operation is the upper die moving down to preform the tube, and then we will use a cam to move in to form the side of the tube. There are 2 more cams I need to define here. Again, I'm going to pick add cam 2, right, and then click define and select surface options and pick this surface here and click include and then followed by exit. Okay, going to turn off my band operations here. Okay, and hydroform operations. So again, the direction of the cam form is not correct. We are going to change this one to -Y directions by keying in -1 and 0. Okay, click OK. I have a stroke of 30. Next, I need to define the cam process. We have to pick synchronous option here and use cam 1. That means cam number 2 will move together with cam number 1. All right, so that's what it means by synchronous. Because the stroke of cam number 2 is 30 and cam number 1 is 20, I'm gonna go to adjust this to 20. Okay, so that they are sharing the same termination time. Okay, I'm gonna add the final cam again. So click create, and then use select by surface options and pick this surface here. Click include and click exit. So again, the working direction is not correct. In this case, we will use -y and 0. Click OK. Define the cam process. Again, use the synchronous options. And this time it's cam 1 and cam 2. So once it's done, you kind of able to preview the preform operations. All right, you can preview it, see if it's correct or not before you submit the simulation. If it's good, now you can move on to the final process, which is hydroforming. Now the stroke here is too far up. I'm going to reduce that to let's say 30. Okay, so change the stroke to 30. Now I'm going to define the pressure. There are two options to define the pressure. We can use either pressure or volume options. In this case, we will use pressure options, and you can use a linear input or user defined. Right? I will use a user defined and click define, and then add the pressure profile. In this case, I will create 3 points. All right, first point is 0, 0. Second point is 0.05 with 20 megapascal pressure, and then the third point is, let's do it 40, and then the third one is, let's say 0.1 with 200 megapascal. Okay, once it's done, you can click apply to create the pressure profile here, and then click OK. You can create any kind of profile here, or you can import your own pressure profiles. It's purely user defined. All right, and then you can key in the durations. In this case, we will use 0.1, and now it's done. The next thing you want to do is to preview your hydroforming process. If it's okay, closing. Of course, in some cases, you will need to add the end plug here, left and right. We don't have it in this case, but if you have it, you can add start pistons or add end pistons. You can add that and then define the velocity or displacement curve for the particular end plugs. So we can go to click control to see if we want to change parameters. These are simulation parameters, able to modify them. Right? If you don't want to do that, then you can click jobs and then submit these simulations. Again, I'm not going to run the simulation here because I already have a result here. In this case, we can start from the beginning. Okay, click here. Okay. I have the tube bending. We can play a tube bending. All right, the first bend, second bend, right, and third, and the fourth. Something just spooky just happened. I apologize. All right, so I have the results, and then the tube's being bent. Now from OP30, this is preform. That's preform. So we move it down and then preform. Now from OP30 to 40 here. This is hydroform. Okay, so, and then we have the OP40, which is trimming operations. So that's the end of this, and then you can look at it. Because we're using a DP600, so the deformation exceeded the material limitation, so we see a lot of cracks in this example here. But that's okay, you know, we can modify the pressure profile, the feeding, you know, and also the material types, even the frictions, you know, kind of improve the formability of this product. That is the end of my presentations.
Hello again, everyone. Thank you for attending the Dynaform 6.2 technical presentation. The team at ETA hopes you found it helpful. If you wish to learn more, please email us as sales@eta.com or call us at 248-729-3010. You're also welcome to visit one of the links displayed.